Hello, everybody. We'll continue chapter 4, and this is 4.4, which is the first section of optimization section. And the next one will be optimization 2. And in this optimization topic, we try to find, for example, what is the absolute maximum and what is the absolute minimum. And these are called absolute extrema. So we are interested in the max and the min. Let's define the absolute extrema here. Um, if you have a function such that f of c, so c is a point, is greater than or equal f of x for all x in the domain of f, then f of c is called the absolute maximum value of f. And similar thing for the absolute minimum with f of c being less than. Some charts to explain this. So if you have this function, 0 and f of 0 is the absolute minimum because and it has no absolute maximum, and you can see f of 0 is the lowest point. For this graph here, f of 0 is its highest point, so that's the absolute maximum. And for this graph, a square root of 2 of 2 somewhere here is the absolute maximum, and negative square root of 2 of 2 somewhere here is the absolute minimum. So this has both. The others, this one has just the absolute minimum, the other has the absolute maximum. And look at this graph here. What we have is the graph its end behavior is toward the positive infinity on the right and negative infinity on the left. So there is no maximum because we need that point C, right? And it's not there. So this has no absolute extrema. Absolute extrema on a closed interval. A lot of investigations sometimes happen on some specific interval. And theorem 3, if a function f is continuous in a closed interval ab, then f has both an absolute maximum and absolute minimum. So if it is continuous there, right? So if an absolute extremum of a continuous function occurs at a point in an open interval, then it must be a relative extremum of f. And we'll show this in example. So here is a graph for some. Let's do left to right. So so you see that here you have a relative minimum, and this is you have relative maximum. Why it's relative? Because of course it's near the point from the left and right, and also here near the point this relative maximum there, because it's like the highest point near this in this region here. This is the absolute minimum. So you do need the up and down on these. So like it went up, then it comes down, right? And same thing here, absolute minimum. This one, you can call it relative minimum because it is relative minimum for this place or near x3, right? But it is also absolute minimum for the graph because that's the lowest point. When you do the y value, that's the lowest point. And this one, when you do the y value, that's the highest point. So the maximum is the y and the minimum are the y values, but where they happen is the x values. So we will say we have absolute maximum at b, which means at x equal b. And this point is, if it's a little bit higher than this one, this endpoint, it can only be an absolute max or min it can't be a relative because it doesn't have this, right? So by looks like it's not, it's neither, because it's not an absolute maximum and it's not an absolute minimum. So the relative minimum f at x3 is the absolute minimum of f. The right endpoint b is on the interval ab gives rise to the absolute maximum. All right. So at a we have neither, because at the end point you have to have either absolute max or absolute min, or neither. So a little more explanation here. X1, X2, X3 are critical numbers of f. So X1, X2, X3 are critical numbers of f. The absolute minimum of f occurs at X3, which lies in the open interval AB and is in critical numbers of f, right? So this open interval AB, it's having X1, X2, X3. So the absolute maximum of f occurs at B at the endpoint. These observations suggest the following procedure for finding the absolute extrema of a continuous function and a closed interval. So this is are the steps to find the absolute extrema on a closed interval. So first, find the critical numbers of f that lie in the open interval AB. Compute the value of f at each critical number found in step 1 and compute f of a and f of b. So you need to find the critical numbers or points, and after that you will need to find, so you go back to the original function, not the derivative, to find their y values, right? So this is the y values at a and b. The absolute maximum value and the absolute minimum value of f will correspond to the largest or smallest numbers respectively found in step 2. All right, so let's do an example. Find the absolute extrema of the function x squared defined on the interval. You see this is closed interval -1, 2. The function is f is continuous there because that's a parabola or a polynomial. The derivative of f is 2x, right, using the power there. So if we look at if we look at this, so the critical value for a 2x, let's see. So look at here at the interval -1, 2. So let's not forget that. We're working with this function over this interval, and we find the critical point or critical value at x equals 0. And that comes from setting f prime of x to 0 at 2x equals 0. So x equals 0. So we have the endpoints of the interval, -1 and 2, and we have a critical point. So we need to investigate these. So at x equal -1, at x equals 0, and x equal 2. What happens? F of -1 is 1, f of 0 is 0, f of 2 is 4. It follows that 0 is the absolute minimum because that's the lowest, right? And value of f, and 4 is the absolute maximum, and that's the highest, right? This y value is the highest, and this one is in between. So it's not the maximum and it's not the minimum. And 4 is the absolute maximum of the value of f. So this is what you will do through the exercises when it comes to this type of question, right? So we'll so you compare these values, and these are, this is the statement. And if you do the graph, you're going to see what happens between -1 and 0 and 2, right? So it's clearly that the, the minimum is at 0, the maximum is at 2, and you see at -1 is in between. So that's the first part in how you're going to work with it. For the lecture activity, it has 3 questions, and these questions are part of the homework. So working on these homework questions is similar to the lecture activities, like identify from a graph which one is the absolute max or min, or relative max or min, and the others are going to be need some mechanical work there. So for this first question here from the homework 4.4, which is similar to maybe question 2 in the lecture activity, you are given this graph, and of course the lowest, the absolute minimum exists there, and it's at 0, 0, or you can say 0, but the absolute maximum does not exist, because there is no maximum. And remember, these are like infinity going, so there is no max. We need a point that is highest y. For this question, find the absolute max and the absolute minimum, if any, for this function. So some functions is helpful to go back to the background of algebra, and like this is a parabola. We know that this is a is negative, so it opens down, and it's a parabola, so it only has a relative max, and there is no relative min, right? So the process here, there is no interval that's stated, so that's a note, no interval stated. So when you investigate this, we're going to say that this is a parabola, opens down, so it has an absolute maximum and no absolute minimum. That's for sure. So the process is, let's find the first derivative. It's going to be -2x plus 2. And we need to find some critical points. And we set the derivative to 0, and we get x equal 1. And that's where that maximum is going to happen. So to find the point, so back substitute in g of x, not g prime of x, right? That's where it came from. So which is g of 1, and we get 7. And that's it. That's where the absolute maximum is going to happen. That 0.17 is the absolute max. For this function here, number 3, find the absolute max, and similarly, no interval is given. So here we can look at the graph and identify, but if we don't look at the graph, of course, the first step is going to be to find the first derivative. So use the quotient rule. Maybe pause the video there until you come up with it, and match it with this here. All right, so by now everybody should be comfortable in doing these. And once you get this one, we need to find critical point or points. We set to 0. Yeah, there is a difference between having the negative on top or to the side equal to 0. So remember, for this type of question, you can cross multiply or whatever you do, but if this fraction is going to equal to 0, the numerator is going to equal to 0. So we've done a few of these. Or you can cross multiply whatever. The denominator is not going to be 0, right? So so this can only, if possible, of course, then it means this is that. So x equal -1 and 1 when you solve this one. So these are the two critical points that we have. We also investigate the denominator. So these for sure we have critical points. But let's investigate the denominator, because can this, be 0? No, because when you do this, you get -1, which is not a real solution. So that's a check for it. So because critical point, of course, has to do with making the function discontinuous or making it equal to 0. So now we have two numbers that make it 0. After this, we can go ahead and check. So remember, we don't have interval here. So we can say let f of -1 that's -1 over 1, -1 square, it's -1 over 2, and f of 1 is going to be 1 over 1 plus 1 squared. That's 1/2, right? And that's it. So you have a -1, -1/2, and you have 1/1/2. It looks like this y value, of course, is higher than this one. So this is where we have the max, and this is where we have the min. And that's the 2 points, the absolute maximum and the absolute minimum. And of course, I would recommend also you can look at this graph and see how it looks. You should be, we've done in the exercise few like these, so now you see it, you know what's going on with it. And those points should be around here. All right, let's look at this question, number 4. So you see now an interval is there. And also, as discussed, this is also a parabola. And it has, that's a negative, so, right? So the a negative means it opens down, so it has a max. So there is a relative max. It just, we need to see, since we're solving this on 6 to 9, if the relative max is happening on this interval. So that's the important part. So let's do, so Of course, f of x has absolute maximum. The question, but is it in 6, 9? Right. So that's what we're going to confirm. So the first derivative is negative 2x plus 8. Well, we set it to 0. Get the x equal 4. And as you see, 4 is not in 6, 9. So 4 is not in 6, 9. So we can't use the 4. Here, so cannot use x equal 4. So let's check. On 6, 9 what's happening. Which one is lower? Which one is higher? So if you do, which means this f of 6, when you substitute 6 into the function, you should be getting 16. And when you substitute 9 into the function, you should get negative 5. So for this interval, it looks like we have an absolute max here, and we have an absolute min here. So what does this mean? Just a quick thing. Of course, if we graph this function, when you get to 4, it should be something like, I'll do it after that. But the points are given are somewhere here, the 6 and the 9. Maybe we need a bigger space. So let's do it here. So I'm not gonna draw it to scale, just to explain what's happening, right, with this. So you understand in general, when you work on interval, then you keep track of the interval, because this is a 4, maybe a 6 and a 9, somewhere there. So, and let's just do something like that. So the points we're interested in, which is this interval here, maybe around this one here. So 6, let's say the 16. All right, somewhere here, 16, let's say. So it's not to scale, but just to show that what's happening in this case, where the 4 came up outside the interval of 6 to 9, so you're dealing with this piece. So since I'm not drawing to scale, I will do it on this side here and say you're getting something like this. It should not bend down. It should be something like this. And this is the 6, 16, and this is a 9 somewhere. This is -5, right? And of course, the maximum comes somewhere here, the other max. But we're talking about these intervals, so that's why I want to do this to explain that you see now the transition, and you can graph this function and investigate it. But this is what we want to understand, the difference when the previous example where we didn't look at the specific, we just say what is the absolute max. Okay, here is the absolute max, right? It's just the point. So when you graph this thing over its domain, there is an absolute maximum, which is that vertex. Same thing here. What is the absolute max and min? So it means over the domain, and there are two critical points, and that's the 2 points. But now once we get to this, now it's over this 6 to 9. When you do 6 to 9, the critical point you find, it's not there. But so you investigate based on the procedure, you investigate 6 and 9, because remember here, this is the procedure. You compute the value of f at each critical point found in this f of a, f of b, and the absolute is going to be that. And when it doesn't work and you have just your interval 6 and 9, then f of 6 and f of 9, which is the two values here, 16 and -5. So there is no other max, because if the 4 is there, then yes. So this is what the graph for it to help and understand this part. So yes, so this is the absolute max, and this is the absolute min. On the snapshot over 6 to 9. So this is the important part to understand. All right, so we're going to work on another example, and this is -3 to 9, and this is a cube function. So it's broken into parts. Find the derivative. After you find the derivative, find any critical numbers of the function and find the absolute max and min. So similarly, you will, so remember, optimization here is like an application to the work that we did. So in the process, there isn't much new other what you already learned. But what's new here is to understand which one is the max, which one is the min, and why is it a max and why is it a min. So as you see, so the first derivative here, when you do each one, and you get 3x squared with the power rule plus a 6x. And of course, we want it over this. So when you set it to 0, because here nothing makes it discontinuous, you get 3. So you should get 3x plus 6 to 0. 0 product property, you set them to 0 and you get -2. So these are the critical points. And now you have to investigate, you have this interval -3, and let's say 1, and we have 0, -2, and 0. So maybe we do this different color just to show -2, 0. So now we just find g of x of each one. The highest will be the max, the absolute maximum. The lowest will be the absolute minimum, and I think if you try it for -3, you get -4, and for f of -2, you get 0, and for this like -4 and this like 0. But the idea is, of course, you look for which one is the lowest, which one is the highest. So which one is the max, which one is the min, right? In this case, the absolute minimum is -4, and the absolute maximum is 0, which is same for 0, 0. So the y0 is the absolute. And you can, of course, graph and see how are things going for this one. I can maybe drop a graph here and show it to you. Okay, and let's see. Yeah, so we have the zeros just to make sure. And here is the graph. As you see, -4 is the absolute min and 0 is the absolute max. And of course, we're talking about this interval, -3, -3 to 1. You see for this graph, -3 to 1, we have these answers. But if you're talking about the domain, that's going to be a different story, right? Because this graph is going to infinity and -infinity. So there is no absolute max and there is no absolute min there. But since we're talking in one place, in specific area, then we can check that way. Let's look at this number 7 as an application to this. An apartment complex has 102 bedroom units. The monthly profit realized from renting out X apartments units is given by the following function. To maximize the monthly rental profit, how many units should be rented out? What is the maximum monthly profit? So you see it runs into the same thing, whether it's an application or the abstract we talked about, same thing. You see that's a quadratic function, so it's a parabola. That's a negative a. So this is a parabola and it has a maximum. So that's the first thing. To maximize, yes, it's possible to maximize. If it's the other way, then no, it may be a minimize. So what is the maximum? So we go into the same idea. P prime of x is negative 20x plus 1740. P prime of x set to 0. X is 87. So what is, so 87 is there. So now what is this y value of 87? You substitute into P and you'll find 35,690. So that's, yes, so there is a monthly profit. So there is a monthly profit of 35,690 when rented units are 87 units, right? And of course, in terms of point, this is the point. Now that I did these examples that have connection in between, we can look at an example that doesn't get solved. It's still solved the same way, just the function doesn't work maybe the same way. So let's look at number 6. And the function is g of x, 1 over 20 x squared minus 25 square root of x. And same thing, we are interested in looking for these maximum and minimum, absolute max and minimum over this interval of 0, 49. Change g of x to the way we've done it in the past, and find the first derivative, right? And simplify it, you should get something like this, right? When you get, and I think now you remember this picture, right? Of x to negative 1/2, and it becomes that. So here, what I want to talk about, of course, he solved this, so you need to find the critical point. You see here, there is square root of x makes it discontinuous. So square root of x, when it's 0, it makes it discontinuous or undefined. So x equals 0, that's 1. And also, we need to set to 0 the function, because that's the definition of a critical point, is what makes it discontinuous or equal to 0. And now this one would look a little bit different. Let's split it and cross multiply, and we get 250. Then let's reduce the 2 there. We get 125. So we get x square root of x equal 125. Different ways you may think about it to solve, but we've done one. We've done something called U substitution. So this is one way to solve it, where you're going to say that a square root of x is a u. In that case, what is x? It's u squared, right? Because you square both sides, you will get u squared. So x square root of x becomes u square u, right? Because of that. So step 1, that's the step 1 of this u substitution. And let's do it here. Equal 125. Of course, that's a u cube equal 125. And that makes it kind of easy to see and solve, which means u is 5, right? So remember, the equation doesn't have a u, it has x. So step 2, we're going to use back this to switch back to x. So if u equal 5, and square root of x equal u, right? That means square root of x equal 5. So x equal 25. So that's what makes it 0. So we have now few points. Remember 0.49. So let's do this. You have 0. We're investigating 0 to 49. We found the critical point 0, this one here, but it's already one of the intervals points or end points, so it's okay. So we won't write 0 twice, so that's already used. And 25, let's say here. So these 3 points we're going to investigate again using g of x. So I would let you try, but I'll show one of them. So in g of x, 1 over 20 x squared minus 25 square root of x, if you put 0 there, you're going to get 0. Then this is going to be 1 over 25, 1 over 20. Uh, 25 squared minus 5 minus, let's make sure, 25 square root of 5. Square root of 25, right? And this one, 1 over 20, 49 squared minus 25 square root of 49. So you get 25 squared over 20 minus 25 times 5. And this one, 1 over 20, 49 squared minus 25 times 7. Let's just do it. So this is 0 and 25 here and 49 here. This one, g of x, we found that this is 0. So for this next one is 25 squared over 20 minus 125. 25 squared over 20 minus 125. This one, 49 squared over 20 minus 175, right? So here just to show, so when you get to it, you deal with the fractions because you want to keep it in a fraction form. So we will need to do the common denominator, right? 20, 20. It's not clear. You need to do the common denominator for each one and solve, right? And simplify. So we need to figure it out. And same for this one. And simplify if it simplifies, right? Simplify if it simplifies. Of course, this one here would simplify to negative 375 over 4. And this one probably about 1099 over 4. Then you check the value. What is this one? Which one is the absolute max, or which one is the absolute min? So for this one, let's check, and this one, let's check. I'm doing the pencil because we're not going to use these values. We're going to use the fractions. So maybe around this, and this is negative 54, about like this. So the lowest point, negative 93, compared to negative 54 is this one. And the highest point, this is not a high, so this is the highest point. So this is the absolute max, and this is the absolute min for this problem. All right, thank you. So please make sure you check the difference between each one, whether you're working over the domain or whether you're working on specific interval. And that's it. Thank you.